Okay, so today we're going to talk about lesson 4.4, which is our non-special angles. And we're going to talk about our angles that would be on the unit circle. Remember, when they're on the unit circle, we know that the radius is equal to 1. Now, let's take a look at an example here. We're given the following point: radical 2 over 5, comma, negative radical 23 over 5. Now, the first thing we want to check to determine if it's on the unit circle or not is we want to, when we think about your picture, in this particular point is going to be down in the fourth quadrant because our x value is radical 2 over 5 and our y value is negative radical 23 over 5. It's this point down here. Now, when I go ahead and check to see that it is on the unit circle, this value here should be 1, which if we check the Pythagorean theorem, that would be radical 2 over 5 squared plus negative radical 23 over 5 squared would equal 1. Now, if I go ahead and check that, if I square that, that's going to give me 2 over 25 plus 23 over 25, which we know 25 over 25 equals 1, so that checks out. So this point is on the unit circle. Now we're going to, also in these problems, we're going to find theta and we're going to find alpha. So in this problem, we know this is theta, and we know this is alpha. Again, alpha is the angle in the triangle. So technically, as I'm finding here, the sine of theta, the opposite over the hypotenuse, that gives me negative radical 23 over 5. My cosecant theta is the reciprocal, so if I do 5 over negative radical 23, that simplifies to be negative 5 radical 23 over 23. If I find the cosine theta, remember, is the adjacent over the hypotenuse, so it's going to be radical 2 over 5. The secant theta is going to be 5 over radical 2, which simplifies to be 5 radical 2 over 2. I do the tangent theta. Tangent theta is going to be the opposite over the adjacent. So notice here, both these are over 5, so I can simply write this as negative radical 23 over radical 2, which becomes negative radical 46 over 2. My cotangent theta, I get radical 2 over negative radical 23, which becomes negative radical 46 over 23. Okay. Now, we found our 6 trig functions. Now we're going to find our theta and our alpha. Now we're going to need our calculator to do this. So alpha is the angle in the triangle. So let's start with that. So alpha, we'd say, if we know that sine is equal to the negative radical 23 over 5, I can do the inverse sine of that radical 23 over 5. Now, again, I'm going to just make that a positive value because I'm finding the angle in the triangle. Now, you could also say that alpha is the inverse cosine of radical 2 over 5. And then we could also use the tangent if we wanted to. We could say that it is the inverse tangent of negative, which we're just going to do the positive here, value radical 46 over 2. So again, we can use any one of those three. I'm going to show you here on the calculator. I'm just going to do the first one, the sine, the inverse sine. So I'm using my calculator. What I'm going to do is I'm going to do the second function, sine. I want a fraction in there, so I'm going to hit alpha and F1, hit 1 so I can get the fraction key. I'm going to do the square root of 23 on the top, 5 on the bottom. And I'm going to put that in parentheses. And then I'm going to go ahead and hit enter. Now that's going to give it to me in decimal form. I'm going to put this, we're going to round this to the nearest minute. So what I'm going to do is I'm going to go ahead and hit second and angle. I'm going to change it to degrees, minutes, and seconds, which is the 4 button. So it says answer DMS and hit enter. So what this tells me here is alpha is 73 degrees, 34 minutes. So alpha, 73 degrees, 34 minutes. So what that value is that's the value inside the triangle there. So for me to find theta, what I have to do is I have to then take 360 degrees minus that 73 degrees, 34 minutes. And when I do that, what that's going to give me, again, if I want to use my calculator here, 360, and that's in degrees, minus 73, again, degrees, and 34 minutes. And I hit enter. And that gives me 286.433, and I'm going to go ahead and change that back to degrees, minutes, seconds, and hit enter. So it gives me 286 degrees and 26 minutes. 286 degrees, 26 minutes. Okay, let's go ahead and take a look at example 2. Again, on this one, we're going to assume that the point is on the unit circle. Now I'm going to draw my picture here. I know that x is negative and my y value is positive, so that's going to put me in the second quadrant. So negative radical 6 over 3 and radical 3 over 3 are my values there on my triangle. And again, we're assuming it's on the unit circle, so my radius is going to be 1. If I find my 6 trig functions, so sine, opposite over hypotenuse, it's going to make that radical 3 over 3. My cosine theta is the adjacent over the hypotenuse, which again, we're saying that this is alpha, this is theta. So adjacent over hypotenuse is just going to be simply negative radical 6 over 3. If I do the tangent, remember it's going to be y over x. So I'm going to do radical 3 over negative radical 6, which when I simplify that becomes radical 18 negative over 6. Again, radical 18, remember radical 18 simplifies to be 3. It's going to be 3 radical 2, so negative 3 radical 2 over 6, which again simplifies to just be negative radical 2 over 2. Okay. Now we're ready to go ahead and find our reciprocal functions. Cosecant theta is going to be 3 over radical 3, which is 3 radical 3 over 3, which is just simply radical 3. Okay. Secant theta, that's going to be 3 over negative radical 6, which becomes 3 negative 3 radical 6 over 6, which becomes negative radical 6 over 2. And then our cotangent theta, if I simplify that, that's going to give me a negative 2 over radical 2, which becomes -2 radical 2 over 2, which is just simply negative radical 2. Okay, so we've got our 6 trig functions there for that one. We're going to go ahead and find alpha. So again, to find alpha, I'm going to do the inverse sine of radical 3 over 3. So again, I need to go ahead and use my calculator here. So I'm going to put that into my calculator. So inverse sine, we're going to do alpha, get a fraction there. So radical 3 on the top and then 3 on the bottom. Put that in parentheses, hit enter. And then we're going to go ahead and take that and I'm going to change it to degrees, minutes, and seconds. Hit enter, enter again. So 35 degrees. Notice here, if I'm rounding it to nearest minute, this 50 is bigger than 30, so 30 bigger than 30 seconds. So 35 degrees in 16 minutes is going to be my alpha. Again, that is the value of this angle here. Now I'm going to go ahead and find theta. To find theta, I've got to take, because alpha here is here in the second quadrant, I'm going to take 180 degrees now minus the 35 degrees in 16 minutes. Okay, so if I put that into my calculator, again, I'm going to do 180, and we're going to say that's degrees minus 35 degrees and 16 minutes. And I hit enter, and then I'm going to change that back to degrees, minutes, and seconds, and hit enter. So 144 degrees, 44 minutes is going to be my theta there. Now, one of the things to keep in mind here, depending on which quadrant your triangle is in, it's important to understand how we find theta. Again, in the first quadrant, theta is going to be equal to alpha. We just did the second quadrant. We know that theta is going to be equal to 180 minus alpha. In the third quadrant, it's going to be 180 plus alpha. And in the fourth quadrant, it's going to be 360 degrees minus alpha. So there's a good little chart there that you can use when you're going about finding theta. Again, fourth quadrant, 360 minus alpha. Third quadrant, 180 plus alpha. Second quadrant, 180 minus alpha. And then in the first quadrant, theta and alpha are the same.